The first Newton's law describes the phenomenon of inertia. You could even say that it's the law of inertia. The red and blue teams compete in a tug of war where the prize is a candy cart. If no one pulls the ropes, the cart is at rest. If the teams pull the cart with the same forces, the cart is at rest as well. Well, in order for the cart to be at rest, it doesn't matter whether the forces that apply to it cancel each other or there are no forces applied. But options give the same result. In this case, in physics, we say that the net force is equal to 0. This is in fact the sum of forces with taking into account their signs on the axis. In our case, one force has a plus sign, the other has a minus sign, and they are equal in magnitude, so their sum is 0. The red team lose one man for a while and then get him back. The blue team accelerated to the left, and when the net force is 0, velocity of the cart stops changing. It's constant again. We see that if the forces applied to an object cancel each other, then the velocity of the object doesn't change. When the cart was at rest, its velocity didn't change either, and just was equal to 0. It's the full description of inertia. This is a phenomenon in which the velocity of an object doesn't change if the net force is 0. In other words, if the forces cancel each other or there are no forces at all. To measure how the phenomenon of inertia affects the velocity change delay, we use mass. Mass is a measure of an object's inertia. So, the more massive the body, the more difficult to change its speed, in magnitude or direction. The first Newton's law works only in inertial frames of reference. The velocity of these frames must be constant as well. The first Newton's law is confirmed by all experiments. As a result, by this law we describe such a phenomenon in our universe as inertia. We know how it works and how to measure it.